Hello and welcome to our educational journey exploring the magnificent star at the center of our solar system, our Sun. Today, we will uncover three key characteristics of the Sun and explore its vital role in our daily lives and the environment. We will also learn how to create a scale model of the solar system to visualize the sun's impressive size relative to other celestial bodies. First, let's talk about what the sun is made of. Our sun is primarily composed of two elements, hydrogen and helium. In its core, an extraordinary process called nuclear fusion occurs, where hydrogen atoms combine to form helium, releasing immense energy that powers the sun. This process is crucial as it fuels the sun and provides the energy necessary for life on Earth.
Let's take a look at the nuclear fusion process that naturally occurs in the Sun and the stars in our truly magnificent universe. Nuclear fusion is the main method used to produce energy in the Sun. Extremely high temperatures and pressures inside the Sun's core provide a setting that is ideal for fusion. The proton-proton chain is a common name for the fusion process that occurs in the Sun. Here are the basic steps of the proton-proton chain. 1. Proton-proton fusion. In the first step of proton-proton fusion, two hydrogen nuclei, or protons, collide, thus overcoming the electrostatic repulsion between them. As a result of this occurrence, a proton changes into a neutron by a process known as beta plus decay, emitting a positron and a neutrino in the process. The second proton is unaltered. Therefore, the end products of this reaction is a deuterium nucleus, which is one proton and one neutron. 2. Deuterium capture. In the second step, a second proton is added to the deuterium nucleus created in the first step, to create a helium-3 nucleus, two protons, and one neutron. A gamma-ray photon is released by this process. This brings us on to number 3. Helium-3 fusion. There are two possible routes for the helium-3 nucleus, created in the step explained. These are: Path 1. Helium-3 fusion. When two helium-3 nuclei collide, a helium-4 nucleus, which consists of two protons and two neutrons, are produced. Two protons, two gamma-ray photons, and a significant quantity of energy are released in this process. Path 2. Helium-3 capture. A helium-3 nucleus captures a helium-4 nucleus to create a beryllium-7 nucleus, which contains 4 protons and 3 neutrons. A gamma-ray photon is released by this process. 4. Beryllium-7 decay. A lithium-7 nucleus, which is 3 protons and 4 neutrons, is created when the beryllium-7 nucleus experiences beta- decay. An electron, an antineutrino, as well as some energy, are released in this process. The lithium-7 nucleus does not directly take part in subsequent fusion processes within the Sun after the beryllium-7 decay. As was mentioned in the earlier steps of the proton-proton chain, the primary reactions in the Sun's core involve the fusion of protons to generate helium nuclei. The proton-proton chain, in its entirety, consists of a succession of fusion reactions that change hydrogen atoms into helium atoms, thus releasing energy in the form of gamma-ray photons and other particles. Our solar system receives heat and light from the Sun thanks to this amazing energy.
Next, consider the size of the Sun. It's a colossal giant, making up 99.8% of the total mass of our solar system. Its immense gravitational pull keeps planets, including Earth, in orbit around it. Imagine the sun as a basketball. In comparison, Earth would be the size of a small bead. The sun's energy output is staggering. It emits light and heat, which drive weather patterns, climate, and support life through processes like photosynthesis. The energy we receive from the sun sustains ecosystems and even powers renewable energy solutions around the world. Beyond its scientific significance, the sun influences our daily lives in countless ways. It warms our planet, dictates the rhythm of day and night, and even affects our mood and health. As you reflect on your personal connection with the sun, consider how its light and warmth shape your everyday experiences and the natural world around you. And to better grasp the sun's size and its relationship with the planets, let's get hands on by constructing a scale model of the solar system. Gather materials like clay or paper and let your creativity shine. This model will help you visualize the sun's scale and its composition among other celestial bodies. For the instructions, use a large ball of yellow clay or a painted paper sphere to represent the sun. Craft smaller spheres for each planet, placing them at proportional distances from the sun. Arrange your planets around the sun, maintaining accurate scale and distance. Through this activity, you'll gain a deeper understanding of the sun's role within the solar system and its relationship with other planets. The sun is not just a star, it's a source of life and wonder, central to our existence and the cosmos. We hope this exploration has deepened your appreciation for the sun's remarkable characteristics and its profound impact on our planet. Thank you for joining us on this enlightening journey. Again, here's Teacher Hazel, your teacher in Science 4.